Hi friends, today I'm going to discuss about ER diagrams. So this is one of the easiest topic in entire database management system, and I am sure that definitely you will get this question in your end exams. ER diagrams, the abbreviation of ER diagrams, entity relationship diagrams. E stands for entity, R stands for relationship. Now see, so before going to discuss about ER diagrams, now I want to give one example to better understanding about entity relationship diagrams. Suppose I want to store student information, so I want to gather all the records of students. So for that, so I need to create one table. So example, this is my table. So if it is a table, obviously you must assign the name of the table. See here, name of the table is student. So this is called student table. So table means it consists of number of rows and number of columns. So here SID, name, login, age, GPA. So these are my column names. So at the same time, I have a 6 records. I inserted 6 students information. 1, 2, 3, 4, 5, 6. 6 records are there, and 5 columns are available in a table. So now what is the table name here? Student is the table name. So also called as an entity. So table or entity. Now, so student is my entity. Now, field names, also called as attributes and columns. Tuples, also called as records, rows. So how many rows? 6 rows. How many records? 6 records. How many tuples? 6 tuples. So at the same time, how many attributes? 5 attributes: SID, name, login, age, GPA. At the same time, how many fields? SID, name, login, age, GPA. So how many columns? 1, 2, 3, 4, 5. So 5 columns, also called as attributes, also called as fields. At the same time, tuples, records, rows. So now this is the terminology which we going to use. So in ER diagrams. Now components of ER diagrams. So here are a few components in ER diagrams: entity, attributes, relationships, so on, from the components of ER diagram, and there are defined symbols and shapes to represent each one of them. So these are the basic components of ER diagram: entity, attributes, relationship. So each and every component has its own shape or symbols. Now, components of ER diagram. The first component in ER diagram is entity. So entity means, so it's a real-time object in the world. Suppose for example, student is one entity, subject is another entity, faculty is also one of the entities. So university, hospital, doctor, so it's an entity. Now simple rectangular box represents an entity. The graphical representation of an entity is a rectangular box. So this is the example, student. So I have to give graphical representation of student is like this. So rectangular box. Next component of ER diagram is relationships. So the association among entities is called relationship. Means, suppose for example, so I have a student entity, so project is another entity. What could be the relationship between this student and project? So allotted is the relationship. Student, allotted, project. So allotted is the relationship between student and project. Suppose another example, student and faculty. What is the relationship between student and faculty entities? So knowledge sharing, teaching is the relationship. So student and faculty, between these two entities, knowledge sharing. So that is another example of an relationship. That's the reason the association among entities is called relationship. Now rhombus is used to set up relationship between two or more entities. So now graphical representation of relationship is rhombus. So this is the Relationship between two or more entities. How many entities here? Two entities. So student is one entity, project is also one of the entities. So in between these two, if there any relationship between these two, so obviously, so we need to give one relationship, that is allotted. Now third one is attributes. Now property of an entity is called attribute. Example, student is there. So what is the property of a student? Hall ticket number, name, age, date of birth, GPA, marks. These are the properties of an entity. So now property of an entity is called attribute. So in this slide, so book is one entity. So author and date of publish. So these two are the attributes of an entity. So now ellipse is used to represent attributes of any entity. Now graphical representation of attribute is ellipse. So now it is connected to the entity. Now weak entity. So another component of ER diagram is weak entity. Now a weak entity is represented using double rectangular boxes. It is generally connected to another entity. So now installment is one entity, loan is another entity. So obviously installment is depends on loan entity. So that's the reason installment is weak entity. So now a weak entity represented using double rectangular. So means installment depends on loan. Next one is now different types of attributes. So entities are represented by means of their properties called attributes. All attributes have values. So for example, a student entity may have name, class, age as attributes. So now, so there are different types of attributes. Simple attribute. So here simple attributes are atomic values which cannot be divided further. So for example, student phone number is a atomic value of 10 digits. So now, so simple attribute means atomic. Atomic in the sense single value. So example is phone number. So phone number means 10 digits, right? 10 or 10 digits. This is called atomic. So example, student name, roll number, date of birth. So roll number is also one of the simple attribute. Now composite attribute. So composite attributes are made of more than one simple attributes. So for example, a student's complete name may have first name and last name. So here name is one attribute. So by using this name attribute, we can further divide into first name and last name. So attribute divided into more than one attribute or further divided into more than one attribute. So this type of attribute is called composite attribute. So obviously single valued attribute. Single valued attributes contains on single value. For example, social security number. So if it is a student, obviously hall ticket number is the single valued attribute. So because, so we cannot assign one hall ticket number or one social security number to another student or another person. That's the reason single valued attribute, single value, it contains single value. Now, multi-valued attribute. Multi-value attribute may contain more than one values. So, for example, a person can have more than one phone number or email address. So now see, student can have more than one phone number 1 and phone number 2. At the same time, so student can have more than one email addresses, email 1 and email 2. So now, multi-valued attributes are depicted by double ellipse. So this is double ellipse. Graphical representation of multi-valued attribute is double ellipse. Now derived attribute. So now graphical representation of an derived attribute is dashed ellipse. Or attributed are depicted by dashed ellipse. For example, age. Age is derived attribute. So why means, so derived attributes are attributes which do not exist physical in the database, but their values are derived from other attributes presented in the databases. Suppose I know the date of birth. So by using that date of birth, so can you calculate the age? So obviously yes, right? So that's the reason age is called derived attribute. Example, age can be derived from date of birth. So another example of derived attribute is, so if you know the total marks, obviously you can calculate the GPA of a student. So here total marks, GPA, these all are so derived attributes. So now see one example. Just I want to construct a ER diagram for university. So means you have to identify the major entities available in the university. For example, student is one entity, exam is another entity, record card is another entity. So these are the attribute, these are the entities I gathered. So if it is a one entity, so has its own attributes. So at the same time, see if it is a more than one entities, in between these two entities we need to provide one relationship. Student sit for exams, exam record, record card, record is a relationship, sit for is relationship, student is one entity, exam is another entity, record is also record card is also one of the entities. Now so each and every entity has its own attributes, property of an entity. Name can further divided into F name, L name. So this is called another attribute. So now here I given underscore student ID underline. So why? Because this is important. So for student, hall ticket number or student ID, so our roll number, these are the important attributes in a given entity. So if it is a important one, you just give the underscore. So why? Because this is a unique field, so also called as primary key field. So we'll discuss later about primary key, foreign key, unique, ordinal, check, default and all. So hope you understand the concept of entity relationship diagrams. So this is the way, so we can draw the ER diagram by using one specific domain. So hope you understand the concept of ER diagram. See if you really like it, share it, and don't forget